The broadcast is now starting. All attendees are in listen-only mode.
All right, folks, if you can hear me, would you raise your hands? If you can hear me, it says Jason, please raise your hand. If you go under questions, there's actually, let me know how many teachers are here, and then we'll get started. Once we get, I'll know that you hear me, and we can get started. I just finished up the other webinar. Let me just step out for a real quick biology break, and we'll get rolling. All right. These people are filling in. I'll let you know when we can start. Sounds like a plan. Kind of waiting on everybody right now. Let me see here. One, two. All right, let me know once we're set to go, folks. Jason, if you would, that'd be great. We have, all right, we're ready to roll. All right. Ready to roll. Excellent. Okay, everybody. Hello, my name is Tom Dubik. I'm a teacher and I co-founded Fly to Learn with Randy Witt, who is with Laminar Research, who makes X-Plane. And I bring this up just so you know where this is coming from. It's a flight simulator, but we wanted to use it to teach kids engineering and not just, there's some wonderful math and science of flying an airplane. And you can use navigation, which uses math. But what I really came from is I started teaching what they call STEM today back in 1989 in terms of engineering. We've always been teaching science and math, but so when I started teaching in 87, I noticed there was nothing for kids that were of a that would make good engineers. And so through the years of teaching engineering with kids, we do a lot with flight because that's always a very interesting topic with the kids. But they'd spend a lot of time trying to make a model airplane. And because they didn't get to work back then, particularly, they didn't get to work with their hands a lot and didn't have really great tools. The planes didn't fly very well. And so you couldn't change the plane and see a really good result. And I was using flight simulators, the popular flight simulator at the time, and to teach them about flight. But they had a version that came out, you could change the wings, but the plane didn't fly any differently. Well, out comes X-Plane. X-Plane does it differently in that it takes the wing, cuts it in other parts of the airplane as well, all the airplane actually. But the part we really worried about, the wing in the 10 pieces, applies the laws of aerodynamics in it, and then puts it all back together again and says, this is how it will fly. So if you design a sailplane, it flies like a sailplane. You design a jet fighter, it flies like a jet fighter. If you design a rocket, it flies like a rock. But that's really good for teaching engineering because now I can change the geometry of the wing and the plane will fly differently. And I, as an engineer, can start looking at the trade-offs that are inherent. And we started this about 9 or 10 years ago before, there wasn't a lot of ways out there to be teaching engineering to kids. I'm really excited. There's tons of new ways to do it. And love to talk to any teacher about teaching and things. Like I said, I'm a teacher. I'm also the director of our department. We're also a fab lab, so we can make almost anything, part of the Fab Foundation. And so with all this in mind, Randy and I created this company that we use an older version of X-Plane that we slightly modify. We use the older one to keep the price down of the software. And also we found that if you were running, say, X-Plane 11 right now, many schools, their computers just couldn't run the program. So with that, that's where X-Plane's coming from. So when the kids fly it or when you're doing it, it's not just about, I'm going to teach you how to fly an airplane. You're going to learn that, but that's not the important part of us. We're trying to teach you engineering, some math, some science, how to apply it. All right. Here's our website. You're going to find everything you need under resources. You don't have to order anything. It's already come in here. Here's the curriculum. I've also got it on downloads here, and the videos are right here at the bottom that go with us. I'm also more than happy to talk with Beth and have more webinars down the road if you would all like to help your teachers train this. And this webinar is being recorded, so you have that. As we go through this, please write a question there. Happy to talk with you. And also, I can unmute your phone if you just want to speak up. Now, let's talk a little bit about this high school curriculum. The high school curriculum, there's a student high school, teacher high school, Gamma Aviation, middle school, and FA. Now, let me share something. You have all the software. Next year, think about entering the Gamma competition. They'll provide you software for free every year, but you design an airplane, and the winning team gets to build an actual civilian airplane, general aviation airplane. So it doesn't cost you anything. It's very exciting. Now, in terms of high school curriculum, let's look at this. I'm going to pull bear with me as the webinar software always kind of gets in the way here. Let's pull this back up. All right, so let me lay out how this follows. You have the science of flight, and then you have advanced topics. So this was originally designed 7th to 10th grade, 9th grade when we did this. You know, the first 5 lessons go great with a middle school, and maybe in 8th grade you can do the engineering design of an airplane kind of thing. But so when you do this, you just figure out these 5 you need. The advanced topics you don't need, but they're requested for those schools that were looking for advanced topics. And then there's the engineering of flight. You do need to do science first, but then you do engineering, and you can get into these more elaborate deals. And if you really want to go more, there's that gamma curriculum that will even go much more in airplane design. You're welcome to use it. Please, that's why I want you to feel free to use that. Okay? Now, I made this suggestion with middle school. I think it applies with high school kids as well. The first time you introduce this to class, let the kids fly and crash the airplane. They don't want to fly, so let them do it. What's nice is you don't need a joystick. You need a mouse. Now, we're going to be sending you some flight controllers down the road that can change the throttle and do things. But for right, I generally that flight controller system you'll get down the road, put it on one computer and let kids do that. But when you're teaching and stuff, just use the mouse. Because here's what happens. You have a room full of kids. I only have 30 kids in the classroom, or 20 kids or 30 kids. You got enough joysticks for everybody. And then one joystick fails. And then you're spending a bunch of time trying to fix that joystick. Or it's a couple joysticks. We just found the mouse always worked. Kids enjoy flying with the mouse. You know, no loss there. All right? Again, we want this to be as many schools as possible. Okay. So we have that. Let me bring up X-Plane for you. I'm going to go down here. Bear with me. Pulling this up, that's Plane Maker. I'm going to get that out of the way for a second. So here's the airplane. Believe it or not, what's great about this is I've got it in flight, but it will show you your lift vectors. We can turn that all off. We're going to all get that in a minute. It'll show you everything. So here you see green, in this case, is the lift. Yellow, the vertical lift. Yellow is the horizontal lift. Right is the induced drag. Now, just in case you're wondering, induced drag is created when you have lift. Parasitic drag is stick your hand out the window of your car. That's parasitic drag. And we spend all this time changing the shapes of the bodies of cars to reduce the amount of parasitic drag. One of the reasons why cars often look a lot, because the engineers are trying to reduce that drag for fuel efficiency, all those good things we all know. All right. On an airplane, you get some induced drag because of lift, but that induced drag is so little compared to all this lift that we're willing to take that trade-off. Also notice, too, on an airplane, the propeller is a moving wing. It's not a corkscrew like an boat. That's how early designers, the Wright brothers, clearly in your state of Ohio, and my parents had a farm in Ohio, knew this. That was one of the great insights. I teach in Charlotte, North Carolina, so they came to Kitty Hawk to take off. Kind of tied in those two worlds. But here we go. So that's what's going on. So here's what you do, though, when you first come in. You go File, Quick Flight Setup. We'll tell you to go and I'm going to just leave it Darlington because that's where we're flying in the last example. Cessna, but we tell you where to go. Clear sky, you fly with these options. And op-ed pops. So always use that Quick Flight Setup when you're doing this in class because it's real quick. May I also suggest, don't use a lot of different airplanes. Start with this. We do use a King Air a little bit later, but don't have the kids because they'll immediately go to advanced fighters or, Dreamliner or something, which has lots of, multiple engines, lots of system controls, a lot of high-end avionics for navigation, all these things that we really aren't all that focused on. So you can This stuff here we can pretty much ignore. All right. This is what we're interested in right here. This right there. Okay. Now, any questions at this point? All right. Got no questions. I'm going to keep rolling here. Now, the first lesson is a good indication of the lessons in that it talks about potential and kinetic energy. And then what it attempts to do is show them how to use the software, and then to understand that airspeed is kinetic energy. Okay, good. You're loading the program. Nice. That's great. So that, well, that loads will explain, so you get the philosophy behind the curriculum and how we're doing this. The first lesson, 5 lessons, were about the science of flight. Well, that partially is also teaching them how to use the software, but we're also teaching them some science. So in the first lesson, they learn potential kinetic energy. Yes, potential energy in the fuel, but the potential energy we're really worrying about is altitude. And the kinetic energy is airspeed. And a pilot is all about managing those energy forms. I can remember I met brought to my class a Vietnam fighter pilot. And I was all excited. He came to my class, and it was 45 minutes on nothing but energy management. And it does make sense. You understand where your energy management is. You know where your competitor, your enemy's energy management is, and you find the combination that puts them at a disadvantage. All right, and that's what that's what they do. That was the big breakthrough in the 60s. They used computing power. It was an industrial engineer, it was from the Air Force, started thinking about it, and they started quantifying it, and they figured out, this is what we should be doing. Study their airplane, get their performance, and then figure out where the weaknesses is. Where do you push them in the envelope? So, we're not talking about dogfighting right at the moment. We're talking about just landing an airplane. And what we get the kids to think about, is it safer to be high and fast or low and slow? And the answer is high and fast. You have still a lot of potential energy, and you have a bunch of kinetic energy. If you get low and slow, you don't have enough energy either case. You want to be low and slow when you land, but you don't want to be low and slow and you have to avoid an obstacle or trying to take off. That's what gets you into problems. All right. Now let me know once the program's done loading. First time might take a little bit, because I'll show you how to take off, and you guys can mess taking it off a little bit, and then we'll get on lessons. Now, while it's loading, while everybody's attention, let me just show you some options. See right here? This is a snapshot of everything going on. All right. Let me see here. Pause this. If you notice, the landing gear actually has a value because it's the landing gear sitting down on it. I'm pausing. The landing gear is sitting down in the airplane. Now, is that paused? Jason, you want me to stop talking so you can focus on what you're doing, or you paused the flight sim? Ready to go. We've loaded and can continue. Excellent. Thank you very much, Jason. So you've got it paused. You're sitting there. This is may or may not be up there. The way we can do that is I'll show you in just a second here. Let me get now. Notice the menu goes away. If you go down here, there's no menu. Like, what? You go up there, it drops down for you. And we're going to go to settings, data input, output, and data C. If you don't have it already, go ahead and check these under data C. Speed on the last two, 21 distance traveled, and landing gear vertical forces. Can I talk with your phone on? Hey, Jason, can I hear you? Yeah, great.
I don't know.
Yeah, I can hear you, Jason.
Cool. All right.
Now, you see how I brought up this data input output screen?
Okay. Yeah, we can see that.
All right, so go here, go to settings, data input output, go to data set.
Yeah, we've got, we're waiting on it to load. So.
All right, no worries.
We more. got a blue screen.
Give it a minute. This is a good example why we use the older, it's a demanding program in terms of computer resources.
Mine came up with some file write errors. File write errors.
Yeah.
So I have to move past that.
Okay. I do know that these screws were working. Oh, okay.
Are you all set, or can I show you guys so we can get going? Because I know time is a premium.
Yep. Okay. Yeah, we got some menus going.
All right, good. So now the menus come up. Let me pop up here. Let me show you again how to get that menu. Go up to Settings, Data Input, Output, go to Data Set. And under 3, click here, 21, here, and here, on landing gear. And what those reflect are the graphical and the cockpit displays. You can actually save it to disk, which is a fancy way of saying it saves it like an Excel file. But here's the two we usually use. But if you want to do a deep dive, you use that. You all set?
Yeah, it's got the complaint. But if you said it was working, you want to. Okay. All right. Yeah, we can go on.
All right, so now if I get out of that data set, you're going to see up in this window of data, of information on the airplane. It's giving you your true airspeed as opposed to indicated. Indicated reflects that there could be wind or where you're relative to the air moving over the wing. So we tend to use true, and then distance travel at the end and landing gear. We use the landing gear down the road to tell us when we've taken off. And don't worry, we can graph it. We don't have to worry about reading in the window, but this is just a quick snapshot of what you'll see on the plane. Now, as I go to take off, it's a 3-step process. I'll show you how to do this. We have a video to show too. So you make sure it's paused, turn off the brakes, then you push in the throttle, and then I'm going to mute you for a second. I muted you just so I get this, and I'm going to be loud, and I don't want to. So we're paused. We turn off the brakes, B for brake. It also shows up here. If I hit B for brake and I click on brake, it goes off. See? And then I push that black button in. That's the throttle. Go back up here, use my arrow keys on my screen. Make sure I have that X, this crosshair. And then I unpause it. It may look choppy because of the internet connection. Get to 75 knots. Pause. I'm in a takeoff. And if I hit view chase again, you'll see I'm off the ground. But keep the kids using the W as much as possible. That's where all the instruments are, and that's how you actually fly an airplane. All right. Do you want any luck? Have you tried taking off?
Yep. Sorry.
No worries. Did you get?
Yeah, we're about there. We're if you want to go on to the throttle section and.
Yep. Let's go through. All right. I'm going to go ahead and meet you because breaking up back and forth here. You're right. So let's go on to the lessons because you can all practice this later, and we have plenty of things here. All right. So now if I go back over to my resources, we have first flight. In that first flight lesson, you actually don't really do any really any kind of data collection where you're writing down numbers or parting into a chart. What I do want you to see, and I'm just using the power slide, that you will so you're going to ask these questions. Weight as a force, and we explain that, and we talk about changing gravity on there. So it's a lesson as much about on the four forces of weight and gravity. Let me go pull up high school curriculum here real quick. Teacher curriculum does have the answers in case, so don't feel like if you didn't know anything about flight, you're out of luck. All right, so let me go right down here. So in this first flight lesson, we're not really collecting data in a table. It's more how to use the software, how to fly, and then talk about potential kinetic energy. And we do that by filling out, these airspeed indicators and altitude. And what they learn is you point the nose down to go faster, you point the nose up to go slower. And when we get to weight now, that's where we add weight to the airplane and we look at takeoff distances. So they're going to use that graph I just showed you to collect different takeoff distances and different airspeeds, and then make their own bar graph and then answer questions based on that. So if I go back to my airplane, I'm going to show you how we would collect data on the chart. So we go over here. I'm off the ground. If I go into settings again, go to data input output and go to data C. Let me show you on the video how to do this. Let me go back. Thank you. All right, so what I suggest is when you do this, I turn mostly, like when you come on, it'll have a lot of lines. These are all checked. Uncheck those all, but leave the true airspeed, distance traveled, and your landing gear. And then by looking at where the landing gear all goes to 0, right there, the red landing gear is still 128 pounds. A little farther back, you have the yellow and red, left and right, and those gears off the ground. When you get to here, all of them are 0. Well, then I go up to the top of this line at that point and say, oh, that's the purple line. Oh, that's distance traveled. I'm at 1,370 feet at that point. Yellow line. Oh, that's true airspeed. I'm at 84.28 miles per hour. So that's how I use the graphing in this. All right. I'm going to unmute y'all. Does that graphing make sense, folks? Got a question on that?
Any questions? No question.
Good. So it's a lot more just like a. Go ahead.
No questions.
Okay, great. I'm going to mute you again. All right. So now we're back off. I don't want to do that. All right. I'm going to hide this down here. So then that's what we're doing here. And then you kind of get into trade-offs and you understand why big airplanes require big runways. We also change gravity and we say, what happens if you flew on the moon? And it's very interesting. If you cap that off. Sorry about that, folks. Okay. All right. All right. Now, sorry about that. Hopefully those notifications, my family being very kind, but don't really want it on the webinar. Okay. So now here we go with lift. We're going to do the same thing, but what we do on lift is a little bit differently. This one's you're still going to follow things, but we're going to teach lift by stalling the airplane, which is a little counterintuitive. We're going to cause the plane not to fly. So like when I'm in the airplane, now I'm going to go back outside the airplane here, go into chase mode, which is view, chase mode. All right. Here it is. All right. So there I am, up, down. What I want the kids to see is lift. Let me go on pause this. I'm going to cause the airplane go. All right. If I go inside the airplane, my airspeed is next to nothing, and I'm claiming altitude, and I've got all blue. So let's explain these instruments right now. It's a good time to do this. This is your airspeed indicator. I'm pointing the nose straight up. I'm going. My airspeed's next to nothing, so it's about to crash if I keep doing that. Blue, this is a artificial horizon indicator. It tells me all blue means I'm climbing, all brown, I'm ground. This is my altimeter. The long hand is hundreds, short hands, thousands. This tells you above sea level. This doesn't tell you about how high the ground you are. I know you're in Ohio. It's flat there. But if they fly down to, say, southern Ohio where the mountains are, they'll run into the mountain because they're not above the ground. They're above the sea level. Next is turn indicator. Really don't use this very much. You just, if you keep your wings in here right at that L mark, in 2 minutes you'll turn 360 degrees. This is a artificial turn indicator, or excuse me, this tells you your artificial heading indicator. This tells you where your plane's going, not on a map, geographic map, not through magnetic north. That's what this compass is telling you. This compass tells you if you're climbing or going down. It's vertical airspeed indicator. This is off the chart because I got it pulled up. So it's saying, it's really climbing right at this moment. And there's my tachometer telling how many airspeed. When we control thrust, we control that tachometer. Now let me go back outside the airplane. Well, no, let's unpause it here. I got my square. I'm going to pause it. I'll put the nose down. Oh, pause. I just crashed. My space bar didn't pause in time. So I just got it here. And what you can do is, again, take off. We'll just go through the takeoff. Pause, brakes, push the throttle in, unpause it. I'm running off the runway because I can't really see my screen. Let me blow this up. This is really annoying right now. So if you have this happen to you, just do this, go quick flight setup, and you can go into the map and start. And we tell you in the map, right in the air. So I'm going to unpause this right now, get my arrow up so I can see what I'm doing. Unpause it, take off here in a minute. So I hit pause, turn the brake off, excuse me. Here's my arrow key, throttle it in, go. Let's click it, unpause it. Pushing the nose down, get my airspeed up. It pulls to the left like a real airplane would. Get up to 70, now I'm going to take off. Now, as I start to climb, all right, there's an optimum rate to do this in the nose, and the pilots all talk about it. But Here is the airspeed. A little more blue sky. It's climbing. I'm 1,100, nearly 1,100 feet off the ground, off of sea level, not off the ground. It would be whatever it was before that. Plus, you can tell them it changed by barometric pressure. I'm at full throttle, but let's look outside the airplane. If you're on a PC, you can hit, I think it's, let me see. On a Mac, it doesn't do it. So that's, you have to take shift 8. You know, let me see if they'll do that. Let me try. No. On a Mac, because the Mac keys are taken over, just go up here to view, and it's chase. All right, now what we talked to the kids about, lift is a function of airspeed, angle of attack. Here's the lift vectors. Now I'm going to climb it. All right. You've changed all that altitude right up there. You can kind of, well, this is not, we could set up lift vectors so you can look at that. But if you look at true airspeed, it's really declining. This airspeed is going to fall. What's going to happen, even though you have full power, you're going to stall the airplane. But watch what happens. You would probably all suspect when I point the nose down, the airspeed is going to go up and I'm going to get more lift. That is very true, but it's actually more than that. Watch when I'm pausing. Going down, I'm getting more lift. I'm definitely getting more lift, but watch when I change the angle of attack. I pull the nose up. I get so much more lift. Lift is a factor of both airspeed and angle of attack. Airspeed and angle of attack. All right? So that's what we show them on lift. We show them what drag is by looking at, and again, they graph a lot of this, by extending the flaps. That's just part of the airplane here. As you increase the wing, it gives you more lift. It also slows you down. Two things you really want to do. All right. All right. Now, and then the last thing they do in terms of the four forces, and they get to use a twin engine airplane at that point. And the last one is thrust, and they use that for landing. And the first few times landing, they're going to crash a lot. So practice that if you'd like. But all you do is you don't point the nose up or down, really. You change the amount of throttle, and that causes you to land. All right? Any questions there on those lessons? Okay, and you'll see there's a chance to fly and land on an aircraft carrier. You can make a whole game out of that. There's a whole range of things. Now, let's get, though, to what I think is really more the engineering side of this. Sorry, I'm going to pull this down here. If you go in where X-Plane's installed on your computer and you bring up something called Plane Maker, I'm going to bring it right up here. This will allow you to change the airplane, and it will allow you then to fly the airplane. So now you get to that idea we have with the RC, the model airplanes in the beginning. Build the airplane and then test fly it. And then iterate. Test it, iterate, test it, iterate, keep doing it. And that's what we start doing on this. Any questions before I go into Plane Maker right here? All right. Now, let me unmute you and see if you can. Jason, anything, any questions?
No questions.
Right. Great. You guys are a quick group. All right. Now, so how do we do this? Well, what we basically do is we file open, and I'm going to say don't save on that. And you're going to get an RB10. And the reason you're going to do this is you're going to open an existing plane, RB10, and then we're going to copy it. And it's those copies that we're going to change. So I'm going to pull up an RB10. Looks like this. It might look like this to you. If you bring it up the very first time, it might even look like this, just a tube to start designing a plane. So we'll go into File, Open, go under Aircraft, go under General Aviation, ban RVs, RV10. Up it pops, spacebar not, it looks like that. Then let's do File, and this says it word for word on the lesson plans. On the lesson plans, it'll tell you step by step. What we're going to do is save them. So first one, I'll just do one as an example. I'll say save as. I tell it to Mr. Kids, Mr. D, this is going to be an aspect ratio, and this is going to be a 50-foot wingspan. And I create it. Now I'm going to put ZZZ here because I already have this on this. So there it is. And down at the bottom, I can see that's the plane I'm working on. So I'll do a 50-foot, 40-foot, 30-foot, 20, 10. I think calls for in the lesson. What we have found is you don't need to worry about changing the body so much. Worry in the beginning about changing the geometry of that wing. It's most bang for the buck. And we look at, so aspect ratio is the width of the wing divided by the chord of the wing. And, so it's, this length across here divided by this length. And if you change that aspect ratio, you shorten it to, if you increase the aspect ratio, they'll discover that you shorten the trade-off distances. But then you also get into, well, why doesn't every airplane look like a sailplane? Why don't we just make all the aspect ratios really big? Because one of the ways to make a big aspect ratio is to make the chord very narrow and the wing length very long, just like in a sailplane. Why don't you do that? And we get into why you don't do that, or what the trade-off is you as the designer has to think about. So, but let's say we have our plane, it's 50 foot. So let's see how we would change it. We'd go to standard then, and we have a tables for you to see. And we go in, there's wing 2 and there's wing 1. In wing 1, under semi-length, right here, you change that to 25. I'm doing this from memory here. We have tables. So that's 25, which at first glance you go, oh, okay, great. It's 20. Oh, look at the wingtips are not there. You can't see it when it's like this, but it's missing its wing, those wingtips right here. So we go back there and we go back to wings, and now we're going to do wing 2. Wing 2 is the flashing wingtips. So we're going to go to lateral arm. Again, it's in a table. You don't have to worry about how we knew that or really show the kids all that much. And you're going to make the lateral arm something like 14.95. No, let's go. Oh, let's make this 24. 20. Wait a minute. 24. $9.5. All right, and then you're going to raise the vertical arm up a little bit. We're going to call that right. So there it is. And now I have an airplane, and I can go ahead and fly that airplane. And I've got mine I've rushed this, so it's off a little bit. The table, it's right on the money. And then you can start flying this thing. And you can collect data. So it's a great way to do the experiments. You don't have to be outside. All right? Any questions on that, Jason?
Okay. And it'll only work on
Any questions?
I think we're about done.
Yeah. All right. And I can show you. Here, I'll tell you what. Let's do this so you know I'm not going to leave you out there hanging. Go over here. If you look on the high school arrangement, this will be lesson 9 under aspect ratio slides, but it's also in the.
Usually it's already logged in.
Guys, that way you can talk. All right, here we go. We get into mathematical aspect ratio. So here's the kind of table we have in there. So it tells you, hey, wingspan 50, wing length 25, wing length is 24.95. I must have done something odd because this is 0.25. This was right. So we will make sure you have every one of those. So it's very easy for the kids to change them. Just make sure they save them, because if they replace the Van 10 there, then you have to almost download another Van 10 and reinstall it. So make sure you copy it. Make sure they use their own copies there. All right? That makes sense, folks? Now, and then you just go right into X-Plane and you can fly it. Look at this. So you do aspect ratio, wing loading, power loading, and airplane design puts it all together, and they get asked a series of questions. Like, so you don't have to necessarily do the advanced science of flight or these things. They're nice things. The runway design's cool. You think about why you're on a runway. You can also see why you can talk about Boeing's plans and the European Airbus. They made their planes really, European Airbus made some really huge airplanes. The problem is now they only have a few airports that can land. And there was the feeling that as you build this, because it's, more people on the same plane, very fuel efficient airplane, that people would all make the runway changes so their airplanes could land there. And not everybody has. So Boeing's strategy was, no, we'll just make smaller airplanes that are more efficient. You'll save on gas, and that's what you'll use. All right. Here it is. All right, let me go to lesson 10. I'm just pulling it because it's probably not lesson 10. It's a little bit past that now. Here, putting it all together. Here's that airplane design. And what this is becomes an exercise in. Let me pull my GoToWebinar software over here, see if I can scroll this down. All right, great. There we go. You talk about engineering method, prototyping, designing your airplanes. It's always a series of trade-offs. Average player weight. Now, the black is the answers that I've already provided for you. Kids don't have it. You figure out what the gross weight is. You make decisions about wing loading, wing area, and you do those calculations. And once you get done with all your different calculations you're looking at and thinking about, and the trade-offs as a pilot, plane maker, you fill out what is the gross weight, what's going to be the fuel and empty weight, what's the wingspan, what's the semi-length or the half of the wingspan. So here's the wingspan. You need half to calculate. You need the chord and you need your rated horsepower. And then you fly the airplane. You see, do you get to the specs that you want to get to? So that's what it becomes. All right, let me pull that up. Okay. It looks like our end session. Thank you for your guidance. Have a great day.